surface deformation video. I've done one of these previously. This one's going to be a little bit different. This one's going to emphasize how to use a grid configuration and modulate it in a certain way. Well, you've seen the intro of the video at this point, so you know what it's going to look like, but I'm going to go into how that happens, so here we go. These kind of animations are a lot of fun to make for me because there's a lot of opportunity to make it artistic, I guess, to mess with the colors and to attach things like certain effects, colors in particular, but other things hinged on like the elevation of a particular vertex or a surface, a face in the animation. So you'll see as I'm creating this thing, I start out with just a basic grid. It's 4x4, or not 4x4, it's a two-dimensional grid. It's square at this point. Doesn't need to be, obviously, but I have a couple of variables that I use to define how many rows and columns are in the grid, and then there's another variable for spacing, and it's potentially there's another variable that I don't use in this animation or this video that would enable me to replicate it along the vertical axis. Well, based on what you're seeing here, it'd be vertical. So it would be layered as many times as I add a number to that variable. So this configuration gives me a great deal of control, and I can't really go into the code too much verbally, but if you want to check out the link that you see, it shows all the code that I'm working on, and you can kind of get an idea of how to, if you're into this sort of thing, you can actually learn how to do it from the code if it's helpful. So I've used this technique previously where I take a distance to the center, or the origin as it's called, and anything beyond that gets trimmed. So I'm populating an array with points at this stage, and only the points within a certain radius. So it ends up being a circle because a radius is a property of a circle, as we know. So I can adjust the size of the radius, the number of rows and columns within, and that's kind of what I'm doing right now. I'm just doing a little bit of fine tuning to get a workable number of points, because I mentioned also previously in videos that I use only software rendering. So my mind is always on performance, because I can't have an animation that's too overly involved, that has millions of vertices or polygons, because the CPU is fast. Modern computers have very fast CPUs, but they're nothing compared to a graphics card, a graphics processing unit, which is massively parallel. It's designed with the express purpose of making graphics extremely fast, and it does it very well. But for a variety of reasons, I don't use that pipeline very often. I have and I can, but perhaps in another video I'll go in depth into why I choose to do software rendering exclusively, which I'm using in this case. So again, my point is that my mind is always on performance. I don't want to have millions of vertices right off the bat, because it's unworkable. It has to be fast enough to be appealing in the end, with a caveat. Now, here's an interesting thing. When I do a final, when I finish an animation, I have to ask an important question. It's a design question, a project question. Do I want this animation to be a live animation where people can look at what you see on the screen, basically, in real time with the canvas, or is it just for processing purposes to eventually become something like a video, basically? Is it just for video, or is it going to be video and canvas? If it's just video, what's interesting is I can abandon all my concerns about bottlenecks and performance issues, because you can record a video that is very slow to record and then speed it up, which is kind of nice. So I do that a little bit just when I'm making animations for production. I don't know how to describe this exactly. If I'm uploading to a website as a GIF or a video, or however you pronounce it, GIF, whatever, I will do a little bit of post-processing, so that it includes some color work, a little bit of saturation. I usually make an inverse, color inverse copy of the same video. And I also speed it up a little bit, because it tends to just look a little bit better. But again, to not beat a dead horse, but with software rendering, you're a little bit limited in terms of how many data points you can work with, or draw, I should say, because the drawing by far is the bottleneck. And you can expect there to be some bottleneck. That's not really a huge problem. It's just the math is super fast. The CPU will just whip right through the math with almost no delay. You can just pile it on. But if you're drawing a great number of pixels, a great number of lines, or filling polygons, kind of like you see here on the screen, I'm starting to fill some polygons and I'm doing some color work, you start to notice a few performance opportunities, let's say, to be positive. But it's getting real close to the goal. I'm almost done. Let's see here. Yeah, so it's basically there at this point, and I kind of get to this point in all of my animations where it's in a finished state, or at least I consider it, I've reached the goal at this point, but I want to optimize it. Now, optimizing is almost a whole separate science. It's a whole subject in itself. It's about kind of what I was talking about, reducing the number of data points, or the number of polygons or lines or colors or whatever, so that you can achieve the balance you're looking for whatever goal that you're actually looking for, if it's a video and or the canvas animation that you want to distribute. So I thought it was fun to look at just the square version of this particular animation, because that looks pretty cool too. I didn't actually end up making that into a final video, but the circular one is the final video. So that's basically it. I'm gonna again put my email address as a contact, so reach out if you have any questions or concerns. If you're into this stuff, I'd love to talk about it. Give me an email or message, and communicate. So that's just about it. Doing a little bit of color changes here at the end, and then I kind of just roll back to where it was about 20 seconds ago in the video, because well, you see I had there's points in the middle of each facet here on this grid, and I thought maybe I could get those into the final animation, but it turns out to be too much overhead, and it's because I'm drawing each point 3 times. I draw a point a certain size, shrink it by a third, and then a third, and then it gives it a nice kind of glowing effect. But anyway, that's the video. Let me know if you have questions. Thank you. Have a good day.